All right, so I'm gonna go over the laws of exponent. Uh, let's start with the first law. It's the multiplication law. If you have two exponents multiplying each other, for example, you have x, some number raised to the power a, or exponent a, times x to the b, okay? So the base is x, the exponent is a. They have to have the same base, x. So the law says this is equal to x to the a plus b. You add the exponents together, okay? So an example of that would be if I have 2 to the third power times 2 to the fifth power, the rule says is the same as or equivalent or equal to 2 to the 3 plus 5 power or 2 to the 8th power, okay? So that's the product rule. All right, so this is one. Let's do the quotient rule. The quotient rule is if you have an exponent divided by another exponent, they have to have the same base again, x. The exponent is a, and the exponent in the denominator is b. The law says this is the same as x to the a, the top exponent, minus b, the bottom exponent, okay? So an example of that, if you have 4 to the third power over 4 to the second power, the rule says it's 4, the top exponent, minus the bottom exponent, and that's 4. 3 minus 2 is 1, and 4 to the 1 is just 4, okay? So that's the quotient rule. Right. Let's do the power rule, okay? So the power rule states if you have x raised to the a and then parentheses raised to the b. In other words, what's in the parenthesis is going to be raised to the power b. The law said that's the same as x to the, let me erase this one. It's the same as x to the a times b. X to the a, you multiply these exponents together. X to the a times b. So an example of that, let's say I have 2 to the third power to the negative 2 power. Let me put in some negative numbers here. The law said it's 2, and you multiply these two numbers together, 3 and negative 2. So it's 2 to the 3 times negative 2, which is 2. 3 times 2 is 6, and a positive times a negative is a negative. So this is 2 to the negative 6. Okay, so that's the power rule. And I think I showed you guys two more rules. Another rule is if you have a fraction inside a parenthesis, let's say you have x to the x over y to the a. Okay, so if you have a fraction raised to an exponent, we can write it as take out the parenthesis and give the exponent to each, to the numerator and then to the denominator. So it can be written as x to the a over y to the a. So it's like raising both numbers, the x and the y, to the a power. And the same applies for multiplication. If you have x times y raised to the a is the same thing as x to the a. You give the a, the exponent, to both of them, times y to the a, okay? All right, so I'll give you an example. If you have 2/3 square, this says is the same as 2 square divided by 3 square. You give the square here and then here. And we know 2 squared is 4 and 3 squared is 9, and that will be the answer, okay? And if it was this one, you have 2 times 3 squared. Then you give the 2 to everything inside the parentheses. So this would be 2 squared times 3 squared. Okay? So those are the only rules or laws of exponents we need. So let me do these examples that we did already using that. So let's do example 1. So this, I'm going to use the product rule. So this is x to the a times x to the b is x to the a plus b. So the base here, x is -2. So this is -2. The base is -2, -2. They have the same base. And you add the exponent. 3 plus 4, which is -2 to the 7th power. Okay, so that's the product rule. Example 2 is the quotient rule. So this is x to the a over x to the b is x to the a minus b. Okay, so 3/7 over 3 squared is 3, the top minus the bottom, 7 minus 2, which is 3 to the 5th power. Okay. All right, so that's the quotient rule. This is the product rule. This is the quotient rule. Let me list them here. X to the a times x to the b is x to the a plus b. X to the a over x to the b is x to the a minus b. X to the a to the b is x to the a times b. X over y to the a is x to the a over y to the a. X times y to the a is x to the a times y to the a. Okay, so this is all the rules we're going to use. So example 3 is the power rule. We're going to use this one for example 3. So let's do it. 15 raised to the 5th power, parentheses raised to the 10th power is 15 raised to the 5 times 10. They multiply each other, which is 15 to the 50th power. Okay. All right, example 8, there's 2 steps. We have to do the denominator first, which is the product rule, and then we have to do the quotient rule. So for example 8, we're gonna do this one first, and then we're gonna do the quotient rule after that, for example 8. So let's do the product rule. So the bottom, the denominator is 2 times 2 to the 9th power. They multiply each other. The first one, there's no exponent. We know if there's no exponent, we put a 1. So this is 2 to the 1st power times 2 to the 9th power. The rule here says add the powers, keep the base. The base is 2, keep that, and add the exponent, 1 plus 9. So this is going to be 2 to the 10th power. 1 plus 9 is 10. So this, the denominator, we just figured that out, is 2 to the 10, and the numerator has 2 to the 4. Okay? We're not done yet. We have to do the quotient rule. We have to do this one now. So the quotient rule says, if you have 2 to the 4th over 2 to the 9th is equal 2 to the top minus the bottom, 2 to the 4th minus the 10, okay, which is 2 to the, what's 4 minus, excuse me, what's 4 minus 10? Well, this is subtraction. If you remember, when it's subtraction, we have to change it to addition using KCC. So we keep, change. Now it's addition. I got a positive 4 and a negative 10. They have different sign. The rule says subtract them. 10 minus 4 is 6. I keep the sign of the number with the bigger absolute value. So we're going to keep the negative 6. So this is going to be 2 to the negative 6. All right. We got one more to do. So let's do the last one, example 9. So let me just erase this stuff so I have some space where I can write. So example 9 is the power rule. So it's, I write it bigger, 3 to the 4th, and that's raised to the 3rd power. So I'm going to use this rule here. So it's 3 to the 4 times 3. They're going to multiply each other. And that's 3 to the 12th power. Okay. And that was the first part we did with exponent.